So we left off before break looking at micrometers and calipers. Today we're going to continue along that same lines, and we're going to look at reading scales and regular meters. And we looked at a couple of ruler tape measure measurements before we got into the calipers. And reading scales really kind of uses the same set of skills as we use there. So let's take a look at our first example here. So for this one here, this is just a simple one scale meter. This needle here, of course, would be on a pivot and it would rotate whichever direction depending on what the input value was into that. To read this, the first thing we have to do is we have to figure out what each single division represents on this meter. To do that, we find two markings that are very clearly labeled. I'll go from 10 to 20, and we count how many spaces are between there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from 10 to 20, that would be 20 minus 10, which is a value of 10 units. Whatever this meter is measuring, that's 10 units. And there were 10 spaces between it. So 10 divided by 10 equals 1 unit for every space. Now that we know that each space on this meter, on this scale of this meter, represents 1 unit, we can figure out where this indicator is at. Now we have two options here. We can either start at the lower number, the 30, and count our way up. So this would be 30, 31, 32, 33, 34, 35, 36, 37. That's 37 units is what that's reading. In fact, we probably could have realized that there's that half mark. We could have realized that's a 35 and just counted 36 and 37. Another option is to take the marking above it and count our way back down to it. This is 40, 39, 38, 37. That was a lot closer, so it was a lot less counting. So whichever way is easier for you. Some people get confused trying to count down like that. Especially, this one was easy because one unit, each space was 1 unit. If it's not 1 unit, it can be a little tricky to count backwards like that. So some people prefer to always count up, even though it's a lot further to count. So here is an example of a meter that has multiple scales on it. So we have to find some sort of indicator of what scale we're using. Here it is this switch down here that is set to the 16 scale. Now the easiest way usually to tell, rather than just using the numbers, is to actually look at how many scales there are, how many settings there are, and which setting we're on. There are 3 settings here, and we are on the middle setting. So if we look at our numbered scales up here, this is obviously the lower set of numbers, and this is obviously the higher set of numbers. We're on the middle setting, so we're going to be using the middle set of numbers here. So it'll be those. So now for that middle set of numbers, we need to figure out what each division here on our scale represents. So we go to, again, 2 clearly marked ones. I'm going to go from 11 to 12. 12 minus 11, that's going to be 1. This is in volts, so it's going to be 1 volt. And we count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. Now, I could have counted to 5 and said, well, that's halfway. We know this is another 5, and just double it rather than have to count all of them up to 10. So 1 volt divided by 10 spaces, that is 0.1 volt per space. Each space here is 1/10 of a volt, or 0.1 volts. So we find here's our needle here, our indicator. Find a marked value. Remember, we're still using that middle scale, so let's use the 12, and we can count our way up. So 12.1, 0.2, 0.3, 0.4, 0.5. Again, we probably could have found that middle point and just do it was 0.5 if we get good at it. 12.6 is where that ends, 12.6 volts. Or we could have done the 13 and did 0.9, 0.8, 0.7, 0.6, counted back to 12.6. When we get decimals, it becomes a lot more difficult to count backwards for most people. So a lot of people like to count up, even though it's a little bit further again. Not all all of our scales are as straightforward as those first two. This is a resistance meter measuring ohms, and ohms are not measured in what we would call a linear scale. It's measured in what's called a logarithmic scale, and it's backwards. The meter itself actually measures the amount of current flowing, and so the more current flows, the higher the needle is. So if there's no current flowing, the needle would stay over here at an infinite resistance. So anyway, for these algorithmic scales, you can see this distance on our scale is just 1 unit over here, where over here that same distance, actually a little bit smaller, is actually 10 units. Over here, that same distance is hundreds of units. It actually goes up to infinity there. So we can't just find two numbers and count the spaces and divide them out, because the value, the size of each space, depends on where we are on the scale. So we have to look at where our indicator is, because this is obviously our needle here. And we look at the numbers around it. So we've got a 7 that's on the smaller side, a 10 on the larger side. And probably the easiest way to do this is to attempt to count up and see if we get from the smallest number to the largest number correctly. If not, we go back and try to count up differently. This is 7. If we do 8, 9, 10, that ends up being the right number for the 10. So that was on the 8. Now we do have to be careful when we read these scales. We have to look for any indicator on that meter. There is a multiplier. And this meter does have a multiplier. Times 1, times 10, times 100. It's indicating the times 1,000. So this isn't just an 8, it's actually 8,000 ohms. Some of our meters have what's called an idler needle or a change. The idler needle, you can actually set it at a reading, and then if you change something, you can see the idler needle will still be sitting where the needle was, and then the regular needle will move to a new spot, so you can see the difference between them. The idler needle actually is a knob on the top of the face of the meter. You turn it so it sits over the top of the regular needle, and then if the regular needle moves, you can see how far it's moved, because it's called an idler needle, or sometimes called a tracking needle. Either way, it's manually adjusted, so you set it over the top of the regular needle so you can see if it moves. So here, this is at a 40, well, there's 40 and 50, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So 40 to 50, 10 units divided by 10 spaces, that's 1 unit per space again. This is 40, 41, that's just at 41 there, units, whatever that gauge is measuring. Over here, this is 20, 21, 22, 23, 24, 25, 26, 27 units. So we have the two readings. So this needle has changed. If this was the tracker here, this is the actual needle, I'm just going to say real needle, it has gone down 41 minus 27, 14 units. So this is back to that resistance or ohm meter again. Once again, we're going to have to count up. So this is 1, this is 2, 1, 2, 3, 4, 5. There's actually 6 there, so it's not even the same. When you start at the 1, the spacing is not even the same as once you get to the 2. But either way, that's about halfway. I'd say 1.4 or 1.5 is what that's saying. Let's just call it 1.5. And again, we have to look for a multiplier. This is on the times 1. So that is just 1.5 ohms. That meter is to reading. So we have another one that's a tracker. This lighter one, lighter dash line, is the tracker again. That is still at 41 units. These are still 1 unit per space, the same scale. The more you use the scale, of course, the more you get familiar with it. And the ones you use over and over again, you'll know what the spacings are. This is on the half point, so we know that's at 55 units. 55 minus 41, this is a positive 14 units. It is increased by 14 units. For the last example, it had decreased by 14 units. Okay, this is more for the automotive students that might be in the group. This is an exhaust analyzer. It measures hydrocarbons and carbon monoxide output. So if we look up here, there's 2 scales. First, we got to figure out which scale. Well, the indicator's on low. We'll use the lower set of numbers. That's this scale here. 200, 300, that appears to be right in the middle, so it's safe to say that's 250. What that's reading. Carbon monoxide, well, we first look at that needle. It looks like it's pointing at 20, but if we're careful, we look down below here, that's a 1.5, and this is 2.5. That's not really a 20. Again, that's at low. That's why we're using the smaller scale. That's not at 20. It's actually 2.0. The needle is covering up the decimal point. So don't just, when you have scales like that where the needle might cover up part of the number, careful to look at the numbers before and after to make sure that you do understand exactly what that number is that's being partially covered by the needle. That's one that a lot of people make a mistake on, just call it 20 because they missed that decimal point, because they don't look around at the other number. Okay, so this is actually an old-fashioned amp voltmeter, current voltmeter, analog. We don't use too many analog meters anymore for testing. We use the digital multimeters for testing. But if you have equipment that is running, you're charging on most of your heavy equipment to have a charging meter, so you can tell the output of your alternator, if it's charging the batteries or your coils or whatever, you're putting out the right electrical output. Those will be needle gauges, analog gauges like this. Here for the amps, well, that's pretty obviously pointing right at the 200, so it's 200 amps. For the volts, again, we have multiple scales. Well, it looks like there's only 2 scales here, a high and a low, or a low and a high, however you want to put it. But if we look at our knob down here, there's actually 3, a 10, 20, and 30 setting. This is on the 20, which is telling us we're using that top scale. The 30 setting actually is kind of unique. It actually would require us to add the 2 numbers together. 10 plus 20 makes 30. So we read the numbers off of both scales and add them together. Well, we're on the 20 setting right now, so we're using this top scale. This is 6, 7, 8, 9, 10, so that's reading 9 volts. So in that case, where there's only 1 or 2 spaces between numbers, you can just count up and see if it works out. If it doesn't work, you go back and count again. You might have tried to do 8, 8.5, well, that should be 9. That's not right, because it's actually labeled 10. Right, 8, 9, 10 works. That's on the 9. You could say, well, 8 to 10 is 2 volts. There's 2 spaces. So get that out. This is actually the exact same meter. I got the same slide in there twice, so we'll skip over that one. This one here, it looks like it's the same as the one we had before, but there's a big difference. This is still on low, so we're reading the small scale, so that is still saying 250 units of hydrocarbons. This one, however, is now on high, so we're using the larger scale. That's obviously pointing at the 8 units. Carbon monoxide here, output. So here's another one. Now they're both on, or this one is on high and this one is on low. So on the high here, we're going to look at the top one up here. Now there's a little bit of confusion here. The 2000 looks like it's labeling this, but it is not. 1000 is actually labeling this mark over here. Just ran out of room, so they slid it over. Kind of a poor way of doing it. So this is 1600. This is 1000. This is actually the 1800 here. So this needle is actually at between 16 and 1800. 1700 is what that's reading. Over here, this is low. That's back on the 2.0 units. Well, this is just reading a simple scale again. You look at these from 10 to 20. Difference from 20 minus 10 is 10 units. You count up 1, 2, 3, 4, 5. So there's 10 spacings in between. So once again, this is 1 unit per space. So I can count up. This is just 30, 31. So this is 31 units here, whatever units that meter's reading. This is 10, 11, 12, 13, 14. So this is 14 units on this meter, this gauge. So back to our DC volt gauge again, multiple settings. We're on the 8-volt setting this time. 8 is the smaller of the 3 settings, which we're using this top scale, the smaller of the 3, the 7, 5, 6, 7. So we're using those set of numbers. So we need to figure out, for that set of numbers, what does each space represent? So we've got from 5 until 6 here. Well, 6 minus 5 is this 1 volt. No. We have 1, 2, 3, 4, 5, 10, 15, 20 spaces. 1 volt divided by 20 is 0.05 volts per space. So each space is 500, so 0.05 volts. So this is 7 here, that'd be 7.05. A lot of people would mistakenly read that as 7.1. It is not, because there's 20 spaces between a 1 volt range now, so it's a different amount per space on that gauge. Same gauge, but we're on the 24 volt setting. We're on the highest setting, which means we're using this bottom scale, or the largest set of numbers. So once again, we need to go back and make sure we know what each spacing stands for at this setting. So we might go from 22 to 24, 4 minus 22 volts. We have 1, 2, 3, 4, 5. Another 5 would make 10 spacings. So 2 volts divided by 10 spacings is 0.2 volts per space. So this, again, it's not 0.1 volts, it's actually 0.2 volts for every space. So this is 22, 22.2, 0.4, 0.6, 22.6 volts. So here, we're at the 16 volt setting. We saw before that the 16 volt setting is 0.1 volt per space. We could go through and figure it out again if we needed to. Little set of numbers. This is 13, 0.1, 0.2, 0.3, 0.4. That's 13.4 volts. Or we could have said this is 13.5. We could have counted backwards to get to 13.4 if we wanted. Or we could have, if we really wanted to, count all the way backwards from the 14. It ends up being 13.4 volts is the reading on that meter. And one more of those. We're still on the 16 volt setting, so we're using the middle set of numbers, the 13 and the 14. We know again that it's 1 or 0.1 volt per spacing. So this is 13, 13.5, 0.6, 0.7, 0.8. 13.8 volts. That is. Another type of meter that's common, and I have a lot of examples on here, even though many of you probably won't use this. If you're doing machining, you would use this. If you were doing in automotive, if you got into the automotive machine, like planing heads and blocks and stuff like that, you might use this. This is a surface gauge, and a surface gauge sets the indicator sitting down like that on a surface. And this indicator is actually pressed in to get to 0. So it can either go out and go positive, or it can be pushed in and go negative. You can see here there's a positive and negative direction on this meter. Well, since we're just getting a picture of the meter, we're not watching the needle move, we have to have some indicator. So they give us an arrow here that tells us this needle has moved that direction from 0. So it's moved in the positive direction from 0. Now these surface meters, the needles can actually go around several times. So there's a second little dial down here that tells us how many times it's gone around. Well, this dial is between 0 and 1, which is telling us it hasn't gone around yet. This is 0.01 millimeters. So this down here, this dial is whole millimeters. So it's the 1 millimeters. So we have 0 whole millimeters here. This is positive. And then we read the big dial up here gives us the tenths and hundredths millimeters. This is 10, 11, 12, 13, 14, 15, 16, 17. So it's 0.17 millimeters. Positive 0.17 millimeters is what that's reading. Now this one here, first thing we see is the arrows going that way. This is a negative reading. Come down here, it's between 2 and 3 for this little needle. So that's a -2. It has made 2 complete rotations. And now to read the big dial, we have to go in this direction since it's indicating negative. Now you'll notice in both directions it goes 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Once you go past 50, you have to adjust. This is 10, 20, 30, 40, 50. This is actually 60, 70, 80, 1. So this is a -2.81 millimeters. So there's some pieces there that we have to be very careful. We have to make sure we see the negative, that we don't lose the negative, and we have to make sure that we read the big dial in the correct direction. This is negative, so we had to read it counterclockwise. And we had to count up. Once we hit 50, we had to adjust these numbers to make sure we were still counting up and not trying to count back down. So this one is also negative. Between 0 and 1, so it's 0 whole millimeters. And we read it this way, 10, 20, 30, we'll back off one that's 29 is what that's at. So it's negative 0.29 millimeters. This one is positive. Arrow's going in the positive direction. Down here, this is between 1 and 2, so that's 1 whole millimeter. And now we have to read going around this way. So 10, 20, 30, 40, 50, 60, 70, 1, 2, 3, 4. That is 74 that reads. So positive 1.74 millimeters. Now we notice a little bit of a change here. The first thing that might stick out is this no longer says 0.01 millimeters. It says 0.001 inches. The other thing, a little more subtle, easy to miss, hard to see, is that these are not 1, 2, 3, 4, 5, 6, 7, 8, 9 anymore. It's 0.1, 0.2, 0.3, 0.4. It's a tenth of an inch. Just like with our calipers, we have to adjust our decimal point when we go from millimeters to inches. So this is positive. Never going to be a whole inch. This is past the 0.1. Now it's right on the 0.1, but we look up here, we see the needle is just past 0, which means we've just passed 1 here. It's past the 0.1. Then this is on the 10 here. So 0.110 inches is what that is reading. So this one here is going in the negative direction. So it's a negative. It's at the 0.9. Is it to the 0.9 yet? No, we're going this way, so we're not quite back to 0. So it's not to 0.9 yet. It is 0.8. Negative 0.8. 10, 20, 30, 40, 50. This would be 60, 70, 80. You count backwards. 79, 78 is what that is. The negative 0.878 inches. That's reading. So here, this one is in the positive direction, or arrows indicating positive. 0, this is between 4 and 5. It has just passed 0 here, so it's just past the 0.4. This will be 30. 1, 2, 7.437 inches is what that's reading. So here, this is going in the negative direction. It's between 0.1 and 0.2, so this is a negative 0.1. 10, 20, 30, 40, 50. This would be 60, back off 1 to be 59. This is a negative 0.159 inches. So here's another different type of meter. This is actually a vacuum meter. I throw this in here for some of our degree students to take this course. This is 2.05. Pretty easy to see this is 2.1, 2.2, 2.3, 2.4. A lot of times when there's only a few spaces like that, only 5 spaces, it's pretty easy to see right off what those spaces equal. Otherwise, you can say this is from 2.0 to 2.5. 2.5 minus 2.0 is 0.5 units. There's 1, 2, 3, 4, 5 spaces. So it's 0.1 unit per space again. Here, this is 0 to 50. That's going to be 50 units. Count up, I have 1, 2, 3, 4, 5, and another 5 is 10. That is 5 units per space. This is the middle, that would be 25, 30, 35, 40. So this is reading 40. This is actually DC volts here. 40 volts. So here we have 2 to 4, that's 2 units. 1, 2, 3, 4, 5, and another 5 would make 10. So 2 volts divided by 10 is 0.2 volts per space. This is 6.2, 6.4 volts. That's another one. A lot of people with this. A lot of people try to say 6.2 there, but you got to catch that the spaces are not 0.1 volts or 0.2 volts each. Here's a variation of an ohm meter, a little bit clearer to read. It actually doesn't go up to a 60 and jump up. This actually goes up to 1,000 before it hits. Here, this is 10 and 15. Let's try to count up by ones. 11, 12, 13, 14, 15. That is correct. So this is 10, 11, 12. 12 ohms is what that is. There's no multiplier down here, so it's just going to be 12 ohms. This one's still an ohm meter. This is the 100 ohms here. 50, 10, 20, 30, 40, 50. So that's 120 ohms. Again, really the only way on these logarithmic scales is really to start at the number smaller, the 100, the number larger, the 150, and count up and see if it comes out correctly. So if it does, you know that what you counted past on your indicator is the correct amount. This one here, the needle is directly on the 1K, so that is 1,000 ohms. This one, a little hard to read, this is 5, 6, 7, 8, 9, 10. Well, that's not right. This is actually the 6, 7, 8, 9, 10. So this is between 5 and 6. 5 ohms. Here's another needle from here to here is 50 units. This is DC volts. 10 spaces, so it's 5 volts per space. 100, 5, 10, 15, 20. 120 volts is what that's reading. Back to these surface indicators. A lot of people seem to struggle with these. This one here is going in the negative direction. It's inches, so it's a 0 point. This is between 0 and 0.0 and 0.1, so it's 0.0. That's going this way, so 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6. Negative 0.056, and that is in inches. And finally, this one. This is also going negative. This is millimeters, however. This is negative. This is between 2 and 3, so that's 2 whole millimeters. It's going this way, so 10, 20, 30, 40, 50, 1, 2, 3, 8. 0.58, millimeters. Negative 2.58 millimeters is that reading. The key to doing these is take your time. Don't get in a rush. People get in a rush and they miss something. Careful and take your time. Make sure you know what each unit stands for. On these surface indicators, you need to make sure you know what direction the needle's moving. Careful with that because it's moving one direction versus another. It's totally different the way you're going to read it. With that, out of your book. 209, exercise 4.9, 1 through 41, the odd. I'm reading these types of meters. Also, just to give you guys an idea of our schedule here, we will be finishing Unit 4 Thursday of next week. So we have all of this week and then all of next week. Unit 4 test will be Thursday of next week. Thursday, what is that? April 1st, I believe. No, that is not an April Fool's joke. Thursday, April 1st is that test. We'll have plenty we have almost 2 weeks worth of material between now and then. So that is have your homework to work on. If you want to get started on that, I will be on the network here to answer any questions.